Hello, today we are going to start with exercise 9D, which says exponential functions. An exponential function is a function of the form f of x is equal to a to the power x, where a is greater than 0 and a is not equal to 1. Now there are two types of exponential processes. The one is exponential growth and the other is exponential decay. Exponential growth is a process that increases the quantity over time, whereas the exponential decay is the process that decreases the quantity over time. Let's say if this number is greater than 1, then it will increase over time. And if this number is less than 1, it will decrease over time. For example, if you multiply 0, let's say, if you multiply 0.1 to 0.1, it will be 0.01. Do you understand that if this is less than 1 and it will multiply by each other, the answer would be less than 1, even a smaller answer. Okay? So exponential decay is the process that decreases the quantity over time, and it should be, this value should be less than 1. Okay, now let's see which function represents the exponential growth and which represents the exponential decay. Y is equals a to the power 10 to the power x. So this would be exponential growth, obviously. B, y is equals 6 to the power minus x. 6 to the power minus x means y is equals 6 to the power minus x. It means 1 over 6 to the power x. So 1 over 6 is the number which is less than 1. So it would be exponential decay. Got it? Part C. 3 over 5 to the power x. Obviously it is exponential decay. Part D, y is equals 0.45 to the power x, exponential decay. Part E, y is equals 1.5 to the power x. Yes, it is exponential growth. I hope you would have understood. Now come to the next question. Yes, match each of these functions with its graph. F of x is equal 2 to the power x. Now, it is f of x is equal 2 to the power of x. How do we know which function does it represent? Okay, let's see. You have to check that, put 1 point, this y is equals 2 to the power 0, where x is equal 0. The x would be equal to 0 at y-intercept. Fine? At y-intercept, x would be equal to 0. So let's check where it is. 2 to the power 0 means 1. So let's check where it is. Here it is. Okay, so this represents g. Okay, g of x is equal to 2 to the power x plus 1. Let us just check this one also. G to the power x is equals, put x equal to 0. So it is 2 to the power 1 and it would be 2. So the intercept would be 0 and the coordinates of intercept would be 0 and 2. Now let us check where it is. 0 and 2. So C represents G. Okay. Now h of x is equals 2 to the power minus x. 2 to the power minus x. What does it mean? It means 1 over 2 to the power x. Putting x is equals to 0, this would come out to be 1. And obviously it is an exponential decay because 1 over 2 is less than 1. So the exponential decays graph should be downward sloping. The graph which is downward sloping and it has the intercept, y-intercept is 0 and 1. So h of x is A. Now let's check I. I of x is equals 3 times 2 to the power x. Putting x is equal to 0 in the function, 3 times 2 to the power 0 means 3 times 1, which is 3. So the coordinates of y-intercept would be 0 and 3. Let us check which graph has the coordinates 0 and 3. B. So I of x represents B. G of x. G of x is 2 to the power x minus 2. Putting x is equals to 0. What does it mean? 2 to the power minus 2. What does it mean? Again, 1 over 2 to the power 2. It is 1 over 4. What it is? It is 0.25. Obviously, the function is a growth and the intercept is 0 and 0.25. So, this would represent E. Got it? Coming to question number 3. For each function y is equal to 3 of x, 3 to the power x plus 4, sketch the graph and mark the asymptote as a dashed line if the asymptote is not the x-axis. Secondly, label the coordinates of y-intercept on the graph. Write down the equation of the asymptote. Label the coordinates of one additional point and then state the domain and range. Okay, let's first start with part A. Okay. A. This is y is equals 3 to the power x plus 4. Now when we have to sketch the graph, if you put it on your GDC, the graph would be like this. Even if you do not put it on GDC, you can graph it. How? Put x is equal to 0 in the function. Y would be 3 to the power 0 plus 4, which is 1 plus 4. So it is 5. Okay. And if I take the color, should be blue. Right? Okay. Now this is 1, 2, 3, 4, 5. So the graph should cut at 0 and 5. 0 and 5. Because it looks like this is exponential growth. So the graph would be like this. And what is the equation of the asymptote? Equation of the asymptote can be found by putting x is equals infinity or minus infinity. Okay? If we put x is equals infinity, this term would get to be 0. 0 plus 4. anything with the power infinity would be 0, remember. So y is equals 4. This would be the equation of the asymptote. Asymptote means the asymptote, this is, would be the dotted line of asymptote. So it should be like this. Okay, y is equals 3 to the power x plus 4. Got it? Okay, now we have to label the coordinates of one additional point on the curve other than the y-intercept. Let's just take x is equals 0. Oh, x is equals 1. 3 to the power 1 plus 4, which would become 3 plus 4 is equals 7. So it means point where x is equals 1, y would be 7. Okay, so it would be 1 and 7. State the domain and range. The domain and range, the domain would be all from minus infinity to infinity, all x values from all real numbers. So x would be all real numbers. And what would be the range? Range would be y would be greater than 3 in any case. Okay, because the asymptote is at y is equals 4. Got it? Coming to the part B, next part, where b is y is equals, okay, y is equals 2 to the power minus x minus 3. It shows that the function would be something downward sloping. Fine. Let's just check the y-intercept. To check y-intercept, we have to put x is equals 0. Anything to the power 0 would be 1. So it is minus 2. So obviously 1 and 2, minus 2. And this is 0. So the coordinate of the y-intercept would be minus 2 and 0. Okay, so the graph should cut the x-axis here. Now the next point, let's just check what would be the next point. Putting x is equal to minus 1. Let's just check what happens. 2 to the power 1 minus 3, which means minus 1. So at minus 1, this would be the point where the graph should like this, and it should go like this. Okay, now what is the equation of the asymptote? Check the equation of asymptote. We will put x is equals infinity. Anything to the power minus infinity or infinity is 0, so it is minus 3. The dotted line which would show the asymptote would be at minus 3. Got it? So the graph would be like this. Now, the coordinate of one additional point, you can do it. Putting x is equals 1 or minus 1. I have put it as minus 1. So it is minus 1 and minus 1. Fine. State the domain and range. The domain would be all x values and the range would be less than minus 3. Or greater than minus 3. Fine. In the same way, part C you can do. 2 minus 2 to the power x. Obviously the graph would be upward sloping. If you have any problem, you can send me a message on my YouTube channel. I'll solve this one too. Coming to question number 4, teacher Tom makes a cup of coffee and leaves it on his table. Its temperature is 8 degrees equals 65 times 2 to the power minus t over 2 plus 25, where t is the time in minutes after Tom makes the coffee. State the initial temperature of the coffee. Obviously, what would be the initial temperature of the coffee where t is equals 0? 65 times 2 to the power minus 0 over 2 plus 25. Obviously, anything to the power 0 would be 1. So it would be 65 plus 25, which makes 90. So it is 90 degree. Initially, the temperature of the coffee would be 90 degree. Part B. Find the temperature of the coffee after 3 minutes. Just put T is equals 3 and we'll find the answer. The answer would be 48 degrees centigrade. Fine. Then Tom likes to drink his coffee when it is 40 degrees centigrade or cooler. Find to the nearest minute how long he should wait to drink his coffee. Put H is equals 40 degree and we have to find the time. Plus 25. Now putting H is equal to 0 and solving for T, we will get T is equals 4 minutes, because T is in minutes. So it means he has to wait for 4 minutes to drink his coffee, 4 minutes or later, to get it cooler till 40 degrees. Determine the temperature of the room where Tom set down his coffee. Remember, the room temperature is the temperature where the coffee should not be cooler than that. Okay, obviously it would be an asymptote. It would be an asymptote. So let's just check the time. At the asymptote, H would be 65 times 2 to the power minus infinity plus 25. Putting anything with the power infinity, it would be 0. So 0 times 65 would be 0 plus 25. So 25 would be the asymptote, horizontal asymptote, and it would be the temperature from which it will not get cooler than that. Okay, so H is 25 degrees centigrade. I would just briefly explain question number 5 and 6. The value y of a car in thousands of dollars is modeled by the function y is equals 30 times 0.9 to the power x, where x is the number of years since the car was manufactured. Remember, if this number is, oh my god, so sorry. If this number is less than 1, it means it is an exponential decay. And because we are checking the value of a car, each subsequent year the value of the car will go down. Find the value of the car when it was new. When it is new, the x would be 0. So if we put x is equals 0, 30 times 0.9 to the power 0, it would be 30, which is in thousands. So initially the value of the car would be 30,000. Determine the value of the car when it is 3 years old. Putting x is equals 3 and we'll find the value of the car after 3 years. Let's just calculate it. It would be $21,870. Fine. See, use your GDC to estimate when the value of the car will be half of its original price or original value. If even not taking it as the way, half of original price would be 15. So put it equal to there. 0.9 to the power x. So it would be 15 over 30 is equals 0.9 to the power x, 1 over 2, 0.9 to the power x. We can solve it through logarithm, we can solve it through our GDC. The x value would be equal to 6.58 years. Okay, coming to question number 6. The population of squirrels in a park is modeled by the function p is equals 40 times 1.5t, where t is the number of years that have elapsed since recording the squirrel population again. State how many squirrels there were initially. Putting t is equals 0, it would be 40. P would be 40 because initially the time is 0. So it would be 40 thousands. P square in the park is one. Yes. No, it is not in thousands. It is 40. Estimate the population of squirrels in the park after 2 years. Putting t as 2 will get the value 90. Okay, 1.5 times 1.5 multiplied by 40 would be 90. By plotting a graph on your GDC, find how long will it take the population of squirrels to reach 200. So putting p is equals to 200, 40 times 1.5 to the power t. Now we have to solve it for t. 5 is equal to 1.5 to the power t. We'll get t is equals 3.97 years. Okay. In the same way we can do question number 7. We just have to put the values only in the place of variables. If you start with 100 mg of carbon, find how much will remain after 1000 years. Okay. So putting A0 is equals A is equals to A0 times 2 to the power t over 5730. Putting A0 is equals 100, where A0 is the mass of carbon at time t and A0 is the initial mass. So initial mass is taken as 100 milligram. It's equal to 5730. Calculating it, it would be 88.6 grams. Using technology to sketch the graph, we can sketch it. From 0 to 100, graph appropriate lines to approximate how many years there is until the mass is 75 grams. Putting A is equal to 75, we can find T. And halved means 50. So putting A is equals to 50, we can find T. And find the mass of carbon after 1000 years. Here we will put A is equals A02 to the power 1000 over 5730, and A would be 100 mg, and solving it, it would be 88.7 grams. I hope you would have understood and you have found this video informative and helpful. Thank you very much. If you have any problem, you can send a message to my YouTube channel and comment there. I'll help you.